Okay. Let's have a look here. Just double check that it is graphs we're doing next. No, not graphs yet. Trigonometry equations and then graphs. I think so, but for some reason students screw it up sometimes. Right. If you have your calculator, as an example to get started, using your calculator, I want you to find x so that this is true. So in other words, solve this. And what do we get? You get 30 degrees, yeah? So here you have 30 degrees. Now, if I said solve this, yes, very good, yeah. If I said solve this, what's the answer here? Yeah, 3 and minus 3. So, in fact, these types of equations, they're a little bit like this type in that there's two answers, or more than one answer. Now, if you type in square root 9 on your calculator, which answer will it give you? Yeah, will it give you this one? No. So just like that, with sine, cos and tan, there's a second answer that your calculator is not giving you. For, the 150 answer. For square root, the second answer is easy. If the calculator gives you the first answer, then the second answer is just minus the first answer. It's just a little bit more complicated for sine and cos, but not a lot. Yeah, no, I hate that circle, so that's not how I'm going to be doing it. Here for sine, the second answer is 180 minus the first answer. So that will be 150 and 30. Now you can check that that's right, because if you put sine 150 on the calculator, you should get a half. Sine 150, and I do get a half. So what I'll do first is I'll give you a table for how to find all the second answers for sine, cos and tan. Right, can I scroll down a little bit? So for your trigonometric equations, for sine, and then we have cosine, and then we have tangent. So the second answer is the first answer, 180 minus the first answer. And of course, if it was in radians, it'd be pi minus the first answer. Cosine is 360 minus the first answer, and if it was in radians, for example, it would be 2 pi minus the first answer. And tangent is 180 plus the first answer, and again, if it was in radians, it'd be pi plus the first answer. So this is if you're using degrees, and this one here if you're using radians. No, I'm not talking about that yet. Just relax yourself. Relax yourself. No, relax. So some people cannot contain their excitement that they know about this circle. Yeah. This circle, I won't use it in semester 1. I'll use it in semester 2 when I need to use it. I don't need to use it yet. Okay. So if you want to use it, go ahead. Don't listen to me. Don't take my advice. It's your life to screw up. But if you're listening to me, there's no need to use this circle yet. It will come in time in semester 2. So I prefer to think of these problems like this in my head. We have a table that tells us how to get the second values if we know the first values. Okay? So let's look at... now let me give you a simple one to try, and then we'll do more complicated ones. By the way, in all these examples, x is between 0 and 360 degrees. I prefer to have this half open, yeah?
What's the difference between a degree and a half?
Did you miss this lesson?
Yeah.
Watch the video.
Oh,
Yeah.
boom.
So I prefer to leave this half open because 360 degrees is like 0 degrees because you've gone around once. So we'll leave it closed on this end and open on this end usually. Okay? Can I scroll down? What's wrong, Hisham? What's wrong?
Stupid. Really?
Sorry, but why is it closed and open?
No, it's just my personal preference. Some books will have it closed on both ends. Yeah.
On the exam or allowed to...
No, the exam will tell you in the question. Yeah. Okay, so for example, sine x equals root 3 over 2, and x is between, look, Hisham, look here. I want you to find the two values of x for this, please. Okay, do you have the two answers here? So yeah, using my calculator, I can type in sine inverse root 3 over 2. Sine inverse root 3 over 2 is 60 degrees. So the second answer will be 120 degrees. Yeah. So these are the two answers here. Okay, so that's okay for simple enough questions, but what about something a little bit more complicated? Can I scroll down? Yeah. Okay. So let's say something like this. For example, 2 sine squared x minus 3 sine x plus 1 equals 0. And again, x is between 0 and 360. So when you look at this, you realize, oh, it's actually a quadratic. It's a quadratic not of x, but of sine x. So let's see. We try and factor it here. This will be 2 sine x. Well, it has to be a 1 and a 1. And it has to be a minus and a minus. So is it this? Let's see. That's right. That's right, and that's right. Yeah, it is like this. So although it looks complicated, you actually just have a quadratic, and really now all that happens is you have two equations to solve. The first one is 2 sine x minus 1 equals 0, and the second one is sine x minus 1 equals 0. So this is sine x equals a half. And this one here is sine x equals 1. So the calculator would give me an answer of 30. And so the second answer is 150. And here the calculator would give me an answer of 90. And the second answer is 180 minus 90 is 90 again. So you realize in this case you only really have 3 answers instead of 4. x could be 30, 90, and 150. And if you wanted to check in the exam, if you take any of these angles and put it back in here for x, it will add up to 0 on the calculator. So if I type in 2 bracket sine of 30 squared minus 3 sine 30 plus 1, I do get 0. Now before anybody asks me how to type this in on the calculator, it gets typed in like this. It will look like this on your calculator. 2 bracket sine bracket 30, like this, squared minus 3 sine 30 plus 1, and then when you hit equals you'll get 0. Okay, so this is how you type the sine squared in. If you didn't know that or you're not sure, please write this part down as well. But this is the answer up here: 30, 90 and 150.
That's just a double check.
That's just a double check, yeah. Okay, you wrote this down?
Yeah.
Yes? Yeah, you wrote it? Yeah. Okay, can we do another example now? Yes? Okay. Right, something like this one here. Now this one's a little bit different because the x is not an x, it's a 2x. Later, but not at the start. And we'll still do 0 to 360, yeah. And we haven't done this word yet, but range isn't quite the right word here, just so you know, but we haven't done this word yet. It's not actually a word until semester 2. Does anyone know what you call this? Actually, maybe we've done it. No, it's not called the range.
Radius.
No.
Ratio.
No. This is called the domain. Yeah. So range is actually something else. Yeah. So the domain is still 0 to 360. Okay. So this one is a little bit different.
Domain is the x values.
Yeah. Domain is the x values and range is the y values. Yeah. This one's a little bit different because of the 2x, but it's same idea. You need your calculator. Where I can't see my pen. Where's it? Let's stop. Come on. Where is it? Here it is. Come back. There we go. Right, so we still start the same way. 2x, but instead of x, it's just 2x. Sine inverse a half. So that means 2x equals 30 or 150. So the only difference here is that we divide by 2 at the end. At the end. So 15 or 75. Okay, now let's do an example with radians just to make it a bit different. Let's say we have sine x plus 2 equals a half, and x is between 0 and 2 pi this time.
They equal 50 or
150. Is it important? Okay, go ahead then. Okay. Can I do this one now? Yeah. Okay. Right. So again, it starts the same. X plus 2 equals sine inverse a half. So then we get x plus 2. Now it's not 30 because it's radians. What's that? Pi over 6, I think. Yeah, pi over 6. And the second answer is pi minus pi over 6, so that's 5 pi over 6. So what do I do here? Pi minus pi over 6. Type it in if you don't believe me.
No, I believe you.
Okay, good. Are we happy with that? Yeah. Now, to finish, what do we do? Minus 2 from each of them. So we have pi over 6 minus 2 is the first answer. Oh, you have it there. What is it, the first one? Minus. Okay, and the second one? 0.6179. Yeah. Now you notice that there's a tiny problem here because, well, one of the answers is negative. So what does this mean? Do we... No, actually not reject here, but we do need to do something.
Make it positive.
How do we make it positive? Yes. Yeah. So look, if I just go to the side for the moment, this angle here is 30 degrees, and this angle here, for example, is minus 30. Now, if we look at this minus 30 angle for a moment, yes, it's minus 30, but another way to think about it is as plus 330. I mean, in both cases we make the same angle. We can start here and go around 330, or we can start here and go down 30. But in both cases we end up at the same place at the end. You see what I mean? So, when we have negative angles, there's actually a very easy way to fix it. When an angle is negative and you need it to be positive, we can add 360, or if it's in radians, we can add 2 pi. This also works if your angle is too big. So for example, if I had an angle of 370 degrees, that means you go around once and then an extra 10. So the angle is actually only 10. So my point I'm making is you are free to add or subtract 360 to fix the angle at the end. And the problem is, this one is okay, it's inside, but this one is not okay. So we fix it by just adding 2 pi to it. And what do we get? 4.807, and the other one is still the same. Radians. Okay, so now it's getting a bit more complicated. So if we can write this one down, please. Yeah.
You know, like the pi over 6, I don't have it on my calculator.
No, you do. Oh wait, no, yours is going to give it to you as a decimal. So usually in the exam, it's okay to give the answer as a decimal, but sometimes with these questions it says give the answer in terms of pi. Now it's not going to say for this one because of the 2, it means we can never have this. If this question said in terms of pi, we would stop here. And I'm giving it in decimal form because I want you to see that this is a negative number here. But some of the questions will say in terms of pi for the answer, and if your calculator is not giving you this, then you're going to have 2 choices: either memorize the values or get this calculator.
Okay.
I think this would be wise, yes. Okay, you wrote this one down? Yep. Okay, so let me give you one, not as difficult as these to try. So we'll do it in radians again. We'll say 3 sine x minus 2 equals 0, and x is between 0 and 2 pi. Now, please look here. This is not this, okay? The 2 here is not on the x. It's on the outside. Okay, so don't write it like this. This is not what I mean, okay? It is like this. Try this one, please. Try this one. It's on the outside. Okay, you have this one. So we can say 3 sine x equals 2, sine x equals 2 over 3, x equals sine inverse 2 over 3. So x equals, if I put my calculator in radian mode, oh yeah, the first one 0.729, and the second answer?
2.411.
Okay, so both of these are okay. Yep. Right, now let's look at an example where we have more than one thing going on. Can I scroll down?
Yeah.
So, let's say we have something like this one here. (2x plus 5 degrees minus 3 equals 0). And here the x is between 0 and 360. Okay, so we want to solve this. Now, before I start, I'll just let you write it down. Okay, did you write this down? Okay, so listen please, listen. Yeah, you have this? Yep. So I'll say this. This is very, very important. Very, very important. So listen carefully. The order is really important here. You cannot solve this in any order. You have to solve this in certain steps. If you, for example, take away the 5 and divide by 2, or divide by 2 and take away the 5, you're going to get two different answers at the end. The order in which you simplify and solve this is very, very, very important. You don't have a choice for the order. The order, we have to go I, E, S and F. This is how I remember it. So the I for me stands for inverse. This means get the inverse first. The E stands for extra answers. The S means simplify to X. And then the F here is to fix the answers. So remember, in the last example, one of the answers was negative and we fixed it by adding 2 pi. That has to happen at the end. If you try to fix negative angles early in the question, you won't get the right answer. In other words, it has to go through these 4 steps. And I'll show you these 4 steps now with this example. But just before I do, I just want to talk a little bit about E for extra. In the examples we've done so far, we usually have 2 answers, but sometimes we have 4 answers. So how can we tell how many answers we have? Roughly, we should get twice this number. So if this is a 2, we should have 4 answers. If it was a 3, we should have 6 answers, and so on. Okay, so I'm expecting 4 answers for this equation. 4 answers is what I want. So I'll just write, where's my pen gone? There it is, hang on, sorry. Come on back. There we go. Right, so I'm expecting 4 answers here. So the first step is the inverse. So what I mean by that is get it ready so that you can find the inverse on your calculator. So if I take this over, it'll be a 3, and if I divide by -5, I'll get -5 here. So we have sine 2x plus 5 degrees equals -0.6. So now I'm ready for the first step, which is the inverse. So if I type in sine inverse -0.6, I'll get 2x plus 5 equals -36.87, or the second answer is 180 minus the first answer. It'll be 216.87 degrees. So now I've done the first step, the inverse. Okay, well that's just normal so far. Now the second one is the E step, extra answers. At the moment, I only have 2 answers, and I need to have 4 answers. Does anybody know how to make the extra 2 answers I should have? Not this, no? Not quite. Say again?
360 degrees.
Yeah, that's it. So you make extra answers by adding 360 degrees to the answers you already have. Because remember, if you have an answer of 10 degrees and I go around once and I get 370, that's still the same angle, so it's another possible answer. So you add 360 to both of these to make 2 more answers. So minus 36.87 plus 360. What's it? 323.13 roughly. And then 323.13 plus 360. 683.13. So now I've done this step. And notice that I didn't fix this angle because that's not until the end. Yeah? Which one? Oh yeah, so what I did was I took the first answer, added 360 and made the third answer. And then the second answer I added 360 and I made the fourth answer here.
216.87 plus 360.
Yeah.
576.
Oh, is it? Ah. Oh, I just... yeah, I see what I did wrong. I see what I did there. Right, what is it? 576.87, roughly. Okay, there we go. So this is the first answer, the second, and the third, and the fourth. Nearly, not quite. There's still 2 more steps left. Okay, now to simplify. Simplify to x. These 4 angles, they're not for x. They're for 2x plus 5. So for example, if I have 2x plus 5 equal to some number, and I want the x, I can say 2x equals the number minus 5. So then I can say x equals the number minus 5 divided by 2. So this is what I need to do now to my answers to get the x. I need to take away 5 degrees and divide it by 2. So that's my next step to get the x. I'll take away 5 and divide it by 2 for each answer. So the first one is minus 36.87 minus 5 divided by 2, and that would be minus 20.94. The second one, 105 is it? Yeah, 105.94. And then the next one, 323. 159. We'll just say 0.07. And then the last one, 576.8. 285.9. 285.9. It's okay? Now, that's the simplifying step done. What's wrong, Hisham? It's okay?
Just divided by 2, yeah.
Divide by 2. You take away 5 and divide by 2. Okay, you have this? So lastly is the fixing step. We want our answers to be between 0 and 360. This is good, this is good, this is good, but this is not. We need to fix this. And the way we fix it, we add 360 here. So if I add 360 to this one, yeah, 339.06 degrees, 105.94 degrees, 159.07, and 285.9. In the exam, we usually use 3 significant figures. So if I want to just round it off at the end, this will be 339, 106, 159, and then 286. These are the 4 angles at the end. So you can see, it's not too bad because each question will be the same. It will have these 4 steps: inverse, extra, simplify, and fix. So all of these questions will look like this. What makes it difficult is this is probably new for most people, or at least doing it this way is new. If you have another way to do it, great. I'm not really interested in the other way you have to do it, because in my experience this is the best way to do it. Okay? So if I got a question like this in the exam, this is how I would do it, because this way I feel confident that I'm guaranteed to get the right answer. But with other methods, where they use things like this thing and other stuff, I feel like there's too many opportunities to make a mistake and get the wrong answer. This is just a nice systematic approach to getting to the answer. Go through these 4 steps and you have the answer at the end. Okay? So write this down carefully and I'll give you an example like this to try. Do you have this one? Yeah? Okay, so let me give you one to try now. Maybe I'll give you a cos one to do. Let's see. Okay. So try this one here. 7 cos minus 3x plus 35 degrees minus 5 equals 0. And again, we'll keep the x to be... let's change it a little bit. Let's say it's minus 180 to 180. Now before you start, please note that all this does is change the last step when you have to fix it. So this time you want the answer to be from minus 180 to 180. So if it's more than 180, we take away 360. And if it's less than 180, we need to add 360. So this only affects the final step. Everything else stays the same. Okay, try this, please. Let me just move this over. Okay, nearly finished that?
No.
No. Okay, do we have 6 answers here? Yeah. Right. What's the first answer? The smallest answer. Degrees. Yeah. That's the first answer. That's the smallest answer. Are you sure?
No, it's not the smallest.
Yeah, that's better.
-1, 5, 3.
-153. Yeah? Let's have a look at it.
I think that one is 44.4.
Oh, okay, great. We all have different answers. That's fantastic. Oh, great. Fantastic. Right, okay. So, watch this one again carefully, please. So, first, what's our first step here? The inverse step, yeah. So, let me just turn my pen back on. Right, so the first step is the inverse. So we have cos minus 3x plus 35 equals minus 5 over 7.
5 over 7.
Or 5 over 7. Oh, goodness. 5 over 7. Okay. Because that would be plus and then that would be plus then. So, what are the two answers you get for cos here? 5 over 7. Minus 3x plus 35 equals 44.4. And then the second answer is
315.
yeah, it's okay, I got it. 315.58. What's wrong? Come on. So I think I'll just add in an extra decimal point there. Right. Listen. So that's the first two answers. Now we need to have how many answers altogether? 6. So there's 4 answers missing. So what we'll do is we'll add 360 to these two answers. So 44.42 plus 360. 404.42. And then here when I add 360 onto this one, I'll get 675.58. Okay, and then 2 more. Now, how do I get the next 2, do you think? Add 360 again to the previous 2. So we have 404.42 plus 360. That's 764.42. And then 675.58 plus 360. That's 1035.58. Now, just if I just go to the side for a moment, we have minus 3x plus 35 equals some number, and we want the x. So we can say we'll say minus 3x equals the number minus 35. So then x equals the number minus 35 divided by minus 3. So if we do that, we can get the x. Yeah, do you have the 6 answers here? Minus 3.14, minus 93.5, 140, what's minus 123 is the next one, 0.1. The next one, 146.5. 2 more. What is it? Minus. All right. Minus 243.14. And then the last one? Yeah.
Yeah, well, what the 146 is wrong.
It's wrong.
What is it?
Yeah, it's minus 213.
156.
Okay.
What?
It's 675.58.
Yeah.
Minus 35.
Yeah, minus
675.58 minus 35 divided by minus 3. Yeah, it does. 0.53. Okay. Now, let's look at our answers. We need the answers to be from minus 180 to plus 180. So this one is okay. This one is okay. This one is okay. This one we'll need to fix it. This one will need to be fixed, and this one will need to be fixed. How to fix those red ones?
To add the
Add 360, yeah. So we have minus 3.14 degrees, minus 93.5 degrees, minus 123.1 degrees. Now if I add 360...
It's on the 213, you get 146.5.
But that's not what I wanted. Which one is wrong now?
Nothing. The final answer is 146.5.
For what? This one? Yeah, you add 360. Yeah, so, oh, I see what you mean now, okay. 146.5. What's the next two, please?
116.8.
Okay, and the last one? 26.4. Okay. Well, we're going to round them all off now, so we'll get, what's the smallest one here is minus 123 degrees, then the next one is minus 93.5 degrees. We'll keep it three significant figures. The next one will be minus 3.14 degrees, 26.4 degrees, 117 degrees, and then 147 degrees. Okay, so just write this down, and then I want to show you something here. Yeah? It's twice the number 3. You look at the number in front of the x, and you should have twice this many answers. Yeah? Right, okay, so 1, 2, 3. Okay. Do you have this? Can I switch the screen for a moment? Okay. Can I switch the screen now? Yeah. Alright. So just to show you that this works, listen, Hisham, please. So if I switch to the other computer here, okay, so what I've done here is I've made two columns. The first one starts at minus 180 degrees and increases to plus 180 degrees. And then I put in my cos formula into the B column. So you can see, for example, if I use 180 degrees, I don't get 0. This will equal minus 11. If x is minus 180. So is the first one an answer? No, because we need it to equal 0. What was the first answer we got? It was minus 123. So if I keep scrolling down, trying different values of x, you can see when I get to 123, we have an answer. Now the reason it says 3 answers here is because I have it rounding off. So we'll take the middle one here, 1, 2, 3. But this answer and this one here, they're nearly 0. So this is why. So this is like the first answer here. Let me just highlight that. Good. Yeah. Right, what was the next answer? Yeah, so around about minus 94, 93, 94 should be an answer. So if I scroll down, you can see here it is here. There are the 4 answers. So somewhere around about here is an answer. The next one is about minus 3, minus 4 degrees. So if I keep scrolling down, you can see again, here it is around about here, at about minus 3 degrees. The next one is 26. So again, you can see that you've got an answer around about here at the 26 mark. And then 117, around about here. And then if I scroll down to 147, you can see that's also an answer as well. And then there's no more answers after that. So these 6 answers are correct. If you manually check, there are only 6 answers between minus 180 and plus 180, and these are the 6 answers. So this is why I like this method. It should always work. Yeah?
You won't get 180. You won't get 0 to 1.
Oh yeah, if I go one more, it's going to stay about the same. And I think it will start coming back down now as well if I continue it a little bit more. It will come back down, don't worry. Just a sec. No, that's not right. I was going up for a bit more. Yeah, okay, it comes back down again. So I have another answer, 267 again. But why do I not use this one? Because it's outside the domain that I'm using. Question, yeah?
Yeah, so check my statement right.
Yeah.
So we have negative answers in the second example because the domain is from -80 to 100.
Yeah,
right?
that's it.
So if it's from -360 to 360, we would have negative answers as well.
Yeah. Now, I should also say that I said roughly speaking, you look at the number here, and if it was a 3x, how many answers is that? 6. But it also depends on how big your domain is. So for example, if I go from 0 to 360, I should have 6 answers. But if I make this half the normal size, what do you think happens to my number of answers? It'd be 3 then. But likewise, if we did what you did, minus 360 to 360, that's twice the normal size, so then it should be, oh sorry, let's take this up, yeah. If I go from minus 360 to 360, that's twice the normal size, so I should have 12 answers. So the 6 is only if it's a regular size. If it's half the normal size, it's 3, but if it was twice the normal size, it'd be 12. Now this is only a guideline, because remember in one example we had the same angle twice. Yeah? So then it's like we're missing an answer, but we're not really missing it, it's just it's the same one twice. It's a bit like when the quadratic has the 2 roots which are the same. It still has 2 factors, but really there's only one root, one answer then. So it's only a guideline. In the exam, don't panic if you get less than this. Do panic if you get more, okay? You should not get more than, for example, 6 answers here. You can get less if some of them are the same, but you can't get more, okay? So I'll let you try these for a few minutes. These questions, oh yeah, and just before you do, let me flick back to here and the worksheet. Okay, can you listen? This is about the exam questions. Basically, I have the questions here, 1, 2, and 3 in difficulty as normal. I suppose the good news for you is that in previous years I had only question 2 and only question 3. And these would be like section A maybe, and these would be like section B. But recently they've made these questions a little bit, well actually a bit easier in the exam. So this is why I put in question 1. Because now questions like this, which I would have in the past said are too easy, they're now in section, they could be in section A of the exam. So for me, this is now like section A, and this one here could be like section B. I still think it's good to at least try one of these. There's nothing new in it. They're just longer and more difficult, but they're only more difficult because they're longer. There's not anything new in it. There is just one formula I have to give you. You might find it useful, but I think some people might already know it. Sine squared x plus cos squared x, sine squared x plus cos squared x equals 1. You knew this one already. So this is very useful for when you need to convert. For example, sine squared x is equal to 1 minus cos squared x, and cos squared x equals 1 minus sine squared x. So if you need to change a sine squared into a cos squared, or you need to change a cos squared into a sine squared, you can use this formula to do it. No, we just use this one for converting sine squared and cos squared. We have no way to convert sine x into cos x, and we have no way to convert cos x into sine x yet, but we will soon. Okay, I want you to try some of these for a few minutes before we look at the next topic. basically, you should be able to easily do everything in question 1. They're not difficult. And in question 2, please try to do an example of a sine, a cos, and a tan. I'll let you pick, okay? So you need to do a sine, a cos, and a tan in question 2, but you should do all of question 1. And again, try to do one question from number 4. So number 1, definitely all. Number 2, do a sine, a cos, and a tan. And number 3, pick any one to do. Okay, try these now for a few minutes.
Only at like 1.
In number 1?
No, 3.
Anyone? Yeah. Yeah. To the formula back here, is it? To this? These aren't really notes. These are just me going blah 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 blah. But if you copy it down, please do it a bit more usefully than this. Okay. It was just for me talking. Yeah.
Is it okay if I ask you a few questions now?
No, later, because I want to check if people can do these. So at the end of the class, we can look at it. It's the coursework, is it?
Yeah.
Yeah. You writing this down? Yeah. Yeah. I can switch to the other screen in a minute and have them up on the board. Come on. You can switch it now, yeah?
Yeah.
Okay.
How many minutes do we have to solve question A?
In the exam,
Now here.
I'm going to just let you work on this for 5 minutes.